normally in the center of a large galaxy where you have a supermassive black hole. This place doesn't have young stars. At least, it's not expected to find young stars in that region. You should find older stars because they are part of the early galaxy formation. Just to give you an idea, the Milky Way is considered a galaxy that is approximately, this number varies a bit, but it's around 10 to 13 billion years old. The most precise age calculated for the Milky Way is 13.6 billion years. So you would expect to find very old stars in that region because it's where the galaxy began forming. But here's the interesting part. Astronomers used various instruments, including the James Webb Space Telescope, and pointed the Webb at the center of the galaxy, in a region very close to the supermassive black hole Sagittarius A, which is the supermassive black hole in our galaxy. Right there, the James Webb discovered a star cluster, an open cluster as it's called. Not a globular one called Sgr 13. So far, so good. The thing is, Sgr 13 was already known. It wasn't discovered just now. It has been known for more than 20 years, but the James Webb, with its observation power, managed to see it clearly and then started calculating the age of the stars. And that's where the big surprise came for astronomers. The stars in that cluster are only 100,000 years old. How is that possible? And they are right next to Sagittarius A, where we would expect to find very, very old stars. To compare, for those who don't know, our galaxy, or rather our solar system, is around 5 billion years old. Our sun is 5 billion years old, so they found stars there with 100,000 years. And this is very interesting indeed. Another thing, when the James Webb was pointed there, it managed to record an interference-free spectrum. This is also very interesting. When they conducted the spectroscopic study of that region, the James Webb spectrum showed the presence of frozen water at the galactic center. But how is that possible, right? So folks, it's basically ice. It's water ice, okay? This water ice is normally found in the dust disks around younger stellar objects. In other words, it's another indication that the stars in that region are indeed very, very young. And that's something that puzzled astronomers, right? How can there be a star cluster with stars that are 100,000 years old in a region near the black hole in our galaxy? At the center of our galaxy, where we would expect to find old stars. How could this have happened? All right, according to the researchers, the results they have so far suggest that Sgr 13 migrated toward the supermassive black hole due to friction with the interstellar medium. It may have undergone collisions with other star clusters or even internal processes within the cluster itself, with these stars growing. All of this could have happened at a certain distance. Look how cool it started migrating. And at a certain distance, it ended up being captured by the central gravity of the Milky Way's supermassive black hole. In this process, a shock wave was created, and this shock wave may have swept through the entire cluster. This increase, due to the shock wave sweeping through, is what's needed for the dust and gas to start clumping together and forming more stars. The researchers' idea is that the cluster was there. It migrated near the black hole of the Milky Way, reached a certain distance, couldn't escape anymore, it was stuck there. And in this entire process, a shock wave was generated. This shock wave produced more dust and gas, forming younger stars. So that's why there's a fountain of youth at the center of the Milky Way, and that's the point that intrigued astronomers for a long time. The analysis of Sgr 13, the interpretation of the clusters, is the first attempt to unravel this mystery of over a decade about young stars at the center of our galaxy. Besides Sgr 13, there is another star cluster, the so-called Cluster S, which is even closer and also consists of young stars. They are significantly younger than what would be possible according to accepted theories. That's pretty cool. The discoveries of Sgr 13 provide an opportunity for future research to establish what the connection might be between the immediate neighbor of the black hole and regions several light years away. How interesting is that? The star cluster IRS-13 seems to be key to unraveling the origin of the dense stellar population at the center of our galaxy. It might have happened that way, right? They formed far away but migrated inside and stopped it at a certain distance. All this evidence that the stars are very young within the reach of the black hole may have formed in star clusters like IRS-13. So all those stars we see nearby probably have the same origin. This is, for those who don't know, the first time it's possible to detect star populations of different ages. Hot main sequence stars and young stars that are being born, all of this in a cluster very close to the center of the Milky Way. So there you have it, another research, another study showing the observation capability of the James Webb and the power of this instrument that we have. It was turned towards the center of the galaxy to study this cluster and look at the amount of information it ended up providing us. So folks, this was the video I wanted to bring to the channel for you now. I hope you enjoyed it. If you did, you know what to do. Don't forget the YouTubeistic package. Share, favorite, subscribe to the channel if you're not already a subscriber. Leave your comments about what you want to know. Watch this other video I prepared for you. You'll definitely enjoy it. Until next time.